Hello, welcome back to Statistics with Dr. Platt. Today we're going to be looking at the first of a short series of lessons on scatter plots, correlations, and regressions. A scatter plot is where we take pairs of values associated with the same object, thing, team that describe two different attributes of that thing, and we have a lot of those things, and we place them in the X and Y categories. The X category is the independent variable and the Y is the dependent variable. The independent variable is the one that is changeable or in some ways is the more controlling one. Like a person's age has an effect on their height, or their height has an effect on their healthy weight, where flipping those over doesn't make any real sense. So if we look here, we have a quartet of data values, goals for a team, wins, losses, and goals against a team. And we have a scatter plot showing goals allowed versus losses. As losses increase, the goals allowed tend to increase as well. It might make more sense to plot this the other way around, where the number of goals allowed tends to cause a higher number of wins, or be correlated with a higher number of wins. We need to be careful to not associate correlation and causation. Two things can change in a similar pattern, but one does not cause the other to be the case. Here we have a positive correlation, and if we plot our wins against our losses by highlighting those two columns, insert, chart, scatter plot, we see that we have our series of dots, and we can add a few elements to our graph. We can add chart titles, and okay, this is our losses and the corresponding wins. This has a negative correlation, and if we add a trend line, we see that it goes down. With our trend line, we can also add, and we add our trend line and other things by adding this plus button, equation of the line, and our R squared value. We'll come back to what each of those stand for in a little bit. So officially, a correlation is a relationship between two variables. And how closely they're related is described by the correlation coefficient, the R value, or the rho value if we're dealing with a population correlation. And it can be determined using this nasty formula. Okay. There are ways to make it a little easier by doing some prep work, but let's find the easier way of finding that in a moment. But our correlation coefficient ranges from -1 to +1. A -1 correlation would have the values perfectly matched to the correlation line and drop as you go from left to right. A +1 correlation has everything matched and rises as you go from left to right. Any correlation that is relatively close to +1 or -1 has a strong correlation. So anything plus zero point 0.8 to 1 or -1 to -0.8 is a strong correlation. 0 0.8 down to 0.5, either positive or negative, would give us a moderate correlation. And anything less than 0.5 or greater than -0.5 would give us a weak correlation, with anything truly between -0.2 and zero point 0.2 being no correlation. The sign of the correlation coefficient is going to be the same as the sign of the slope of the line. We can find a correlation coefficient if the sample is random, the data falls in a roughly linear fashion, and is measured at either the interval or ratio level. And we always want to round our R value to 3 decimal places. Okay, so the way we go about doing this is, or to find this, we can either find the R squared value and take the square root of that, or do equals CORL of our two arrays. Back over here. One of our arrays is this one here, comma. Our other array is the corresponding beads. And we have a negative 0.948, which the data is fairly close to our line, and it is definitively negatively sloped. Here we have our losses and goals allowed, and we can find the correlation there equals CORL of C3 through 34 and D through 34, and we have positive 0.902, which is roughly the square root of 0.8138. The slope and intercept of our line has been determined by this equation, which again can be reached or can be obtained by using the plus sign. Let's do one more. Those 4 and losses. Whoops. All right, that's not what we're looking for. Um, so here we have a random looking cluster We can try to add a trend line and more options. Format trend line, display equation, and display R squared value. The R squared value is very small, which will mean our correlation will be very small. And there's not going to be any significant values. All three of these graphs have values that are all inliers. If a single value is way out of place, then it would be considered an outlier or a influencer of our, or an influential point of our line of best fit. As we play more with our formulas, we will learn more about those. So see you in the next episode.